Right. Good evening, everybody. This is a new program that I decided to have. So it's called Final Countdown for a reason. You have 24 weeks for the exam. And I thought it's my duty to make sure whether you are my student or not my student. I want to make sure that everybody passes this exam. So therefore, as a main focus, because majority of the students do not do the past papers. So therefore, as an initial push, just to help you get through this, and at least minimum, even a person who is very weak, if you follow this program for the next 24 weeks, guaranteed you will see an increase in your level. And my only wish is that you see that particular increase in yourself. Remember, passing examinations, especially A-level examinations, there is no magic in it. If you sit, put your effort into it, if you are disciplined enough, guaranteed you will succeed. There is no way whatsoever that there is going to be any failure involved. So my objective, because my favorite subject is physics, my teaching subject is physics, I want all of you all to pass this particular subject. So therefore, as an initial step, just to get all of you going, including my students and all other students in Sri Lanka, as a help to make sure that all of you all get going. And once you all get going, after a few weeks, you will realize that this is not difficult as it seems. And passing the exam, you will get addicted to physics. So therefore, you will enjoy the subject as well. Okay. So today I have already sent you all the papers in the WhatsApp groups. Whoever did not get the paper, please, anybody in the groups can share it among your friends. And I'll be discussing it on the board, so you can follow me as I discuss it on the board. Okay, right. Okay, I'm sure all of you can see this. Right. So here, the way the program is going to go is, I will just give you a small review here. Now, so today we are in week number 1. Today we are in week number 1. Week number 1 has 3 days. So we'll be breaking down a particular paper for 3 days so that everybody will have enough time while studying the other subjects also to do this. So day 1, so the paper is broken to day 1, day 2, and day 3. Right. Today we'll be focusing mainly on the 2000 A-level paper. 2000 A-level paper. Right. So 2000 A-level paper is broken down into 3 sections here. Those days, now you have 50 MCQs. Those days it was 60 MCQs. So I have a small advantage there also to divide this. If I divide this, so every day you're doing 20 MCQs each. 20 MCQs each. Imagine that. Some of you all don't like MCQs. Some of you all are trying your very best to up your level, but however much you try, always you are at the same level. So look, every week, 60 MCQs are there. Isn't that a good advantage? It is a good advantage. Remember, the advantage in you passing the examination is always how much work have you done earlier, how much prepared you are earlier. So this is a good preparation. Yeah, this is a good preparation. So you have 20 MCQs. I think I'll start off with one structured essay and one essay. Here also one structured essay, one essay. Here also one structured essay and one essay. Right. So 60 MCQs, 3 structured essays, and 3 essays here. Now you will say, sir, there is so much of questions in the paper. That means if you take the essay paper, there is one more structured. And normally in a paper, that you have what? Generally you have question number 5, question number 6, question number 7, question number 8, 8A, 8B, or question number 8, question number 9A, 9B, 10A, 10B. So you have 6. What I'm focusing here is the mechanics question, the waves question, and the thermal question. Right. This is a high advantage question. So that even if you're weak, if you can adjust to these, guaranteed you can score. And these are sections that most of you all don't like. Right. Now, what about the rest? How are you going to do that, sir? Don't worry. As we go along, once we finish week number 4, the 5th week is kept to do the other questions involved. So that week, 3 days, will be doing the other questions in the paper. So you will have the other structured essay and also many essays involved. So in that week, 3 days, we'll be doing the papers, the other questions involved. So which will help you to finish all the papers, required papers as well. Is it clear? So as we go along, you will see how effective this is. So biggest effectiveness is you will see that in the first week itself, 60 MCQs you're doing. Now, the ones who have done the paper, I think I sent the paper last Saturday, all 3 papers. So this week you have tried 60 MCQs. Now you will say, sir, some MCQs I don't know. Don't worry. Keep those. In your theory classes, respective theory classes, when you are learning, guarantee those will be covered. And I will also cover it. Here in the discussion, it will be covered. So later after you study, you can do the paper and then check the reference. The reference is there on YouTube. Okay, no? So therefore, all in all, this is a good program for you to up your level and also understand certain sections involved in this. So here you go, 20 MCQs each. Today we start off with one structured, one essay. And this week we'll do it like this. Main focus is on these 3 sections because these are the 3 weak sections of majority of the students. And then as we go along, the field section will come in, the electric field section will come in, the properties of matter section will come in, the electricity section will come in. Like that, sections will adapt. Okay, no? Right. So without talking anything further, I think I have given you a rough preview. These are superb work. It's a big work. If you do this well, imagine 60 MCQs a week, 60 MCQs a week, 60 MCQs a week, 24 weeks, 24 times 2. Forget about some years you have 50 MCQs. No? So around 1200 plus MCQs done. Around 1200 plus MCQs. Imagine the structured essay. How many papers? 24 papers times 4. How much? 96 structured essay. Let's say out of all the essay questions, we target and do about 5 essays. 4 only required. 5 times 24. How much? 0, 12, 120 essays. Now, some of these essays in your theory class you have done. So I normally know what are the questions they normally do. So avoiding those, the questions that is normally not done will be discussed here. So imagine this. If you are in this program, over 1200 plus MCQs done, over 96 structured essay discussed, over 120 essays also done, which is a big advantage for you. Is it clear? Big advantage for you. Right. Let's get back to work. Right. Here you go. This is week number 1. Week number 1. 2000 A-level question. This is your MCQ number 1. MCQ number 1. So I'll push this a bit forward. Right. There you go. So that all of you can see. Right. Right. So I think blue color is good. Just let me know in the chat whether blue color is good or not. Right. Anyways, first question. One of the following units measures the physical quantity that is different from, the keyword here is different. Different from the physical quantities measured by the others. Measured by the others. Please look at the board. Please look at the board. Now, electron volt. What does electron volt give you? Electron volt measures energy. Now, when you do electric fields, when electrons travel, when subatomic particles travel, when protons travel, we'll be talking about what? Electrons. So here, electron volt is a unit of energy. electron volt is a unit of energy. Right. What about watt second? Watt second. Now, what is a unit of power? Power is equal to energy divided by time. If you cross multiply this, power multiplied by time is energy. So watt second is actually a unit of energy. Huh? So watt second is a unit of energy. Watt second is a unit of energy. I have shown you how to get it. Okay, no? Right. Next is kilowatt hour. Kilowatt hour. Now, what is kilowatt hour? Kilowatt hour. Kilowatt hour is where your electricity bill comes from all level time. You all know. So kilowatt hour means same as this. Power is measured in kilowatt. Time is measured in hour. Kilowatt hour is also energy. So here, if I write kilowatt hour is also energy. Kilowatt hour is also energy. Right. What about mega electron volt? Mega electron volt. Mega electron volt is same as electron volt. Mega means 10 to the power 6. So here, mega means a prefix. Indices knowledge. Prefixes we learned in units and dimensions. Mega means 10 to the power 6 electron volt. So that is also a unit of energy. So mega electron volt is also a unit of energy. Now you can write pico electron volt, giga electron volt, all of that. All the indices put together, you have what? Energy. Right. So you can see all of this here is actually a unit of energy. So this is energy, this energy, this energy, this energy. What on earth is this? Joules per second. Energy is measured in joules. Time is measured in second. Joules per second means this is power. So they are asking what is different. So what is different? This is different. Joules per second. Joules per second. Okay, no? Right. Now, if I move this upwards, dimensions of power is. Right. So what do you mean by the dimensions of power? Power dimensions, you can apply dimension equations. So power here is energy divided by time. Energy divided by time. So you can take square brackets. Even the ones who are weak, follow me. Make sure you're writing. Write with me. Write with me. Don't listen and wait. This is not a film. This is not a movie. This is not a YouTube story. This is work. So now take your piece of paper. Take a paper. Write with me. Work with me. Energy. What is energy? Energy dimensions are ml squared t minus 2. ml squared t minus 2. ml squared t minus 2. Time dimensions are time t. Now be careful. Can I cut this? You can't cut this. You take this on top. If you take this on top, you will get ml squared t minus 3. ml squared t minus 3. Where is your answer? ml squared t minus 3. Here you go. That's the answer. Not difficult, huh? Can you see how confident you can get? Not difficult. Not difficult. Right. Okay. I'll move this up a bit. Right. Look at the next one. Look at the next one. Observe. Figure shows a part of a micrometer screw gauge when two jaws are touching each other. Right. Two jaws are touching each other. So the jaws are touching each other. Right. If you look at this, here the 0 mark is there. This mark here, sorry. 0 mark is on top. Sorry. 0 mark is on top. Right. 0 mark is on top. 45, 46, 47. These are the 47 divisions. Right. I know some of you all are weak in measuring instruments. So what I'll do is, I will help you all here. Look at the board below. Right. Look at the board. Now, when it comes to a micrometer screw gauge, here you have the linear scale line. When the anvil and the spindle are touching each other, you have the linear scale line, right? Here, 45th division is here. 46, 47, 48, 49, 0. Now you might wonder, sir, now how do I know how many circular scale divisions are there? Don't worry. 45, 46, 47, 48, 49, 50. You have 50 circular scale divisions. There, 50 circular scale divisions, right? Okay, no? Now you might think, sir, how do I know what is the linear scale? Don't worry. Now in your syllabus, your least count for a micrometer screw gauge is 0.01. 0.01. Now that means if I draw it here, separately, 0 here, 0.51, 1.52, 2.53, 3.54, like that it goes. That means you can see here 0.51, 1.52, 2.53, 3.54. Here 0.5 gaps. 0.5 gaps. Remember the distance between the pitch scale is called what? The pitch. So how do you find the least count? Least count is equal to pitch divided by number of circular scale divisions. Number of circular scale divisions. Pitch is equal to 0.5. Number of circular scale divisions, 50. So your answer is 0.01 millimeters. So that pitch is going to be, least count is going to be 0.01. Right. How do you find the zero error? How do you find the zero error? Carefully look. If the circular scale 0 is above the linear scale line, if the circular scale 0 is above the linear scale line, we can easily say that this is a negative zero error. Negative sign will come. Why? Negative zero error means you're reading less than the actual value. Why? From top only you're starting. So this bit is disappeared. From top only you're starting. How do you find the negative zero error? Very simple. Total number of circular scale divisions. Total number of circular scale divisions is 50 minus the circular scale division in line. What's the circular scale division in line? 47. So 50 minus 47 multiplied by least count 0.01. What's your answer? 0.03 millimeters. Right. So now you have found the least. You have found the zero error. Tell me now, negative zero errors. Negative zero errors. What should you do? Remember, negative zero error means you must add. What? Negative zero error means you can add. Why is that? You are reading a value less than the actual. You are reading a value less than the actual means you can what? Add. So negative zero errors are added. So the correction is, add 0.03 millimeters. Understood? So if the circular scale is above, remember what? Negative zero error. Negative zero error means how am I going to find? Total number of circular scale divisions minus the division in line, that into least count. Here you get 0.03. If it's a negative zero error, that's going to be added. So the correction is going to be at 0.03. Right. Now look below. So what's the correction? Added to the scale. So this is your answer. This is your answer. Added to the scale reading. Answer number 3. Okay, no? Answer number 3. Right. For the ones who need to write this, quickly write down, will write a small sentence. If the circular scale 0 is above the linear scale line, if the circular scale 0 is above the linear scale line, if the circular scale 0 is above the linear scale line, there will be a negative zero error. there will be a negative zero error. There will be a negative zero error. And negative zero errors are added. Negative zero errors are added. Negative zero errors are added. Okay. Quickly write that if you are getting late, because take a photo at least. Then slowly you can look at it. Okay. Right. So I'll move forward. Okay. Here you go. Next one. Next one. Which of the following objects of mass m has the greatest acceleration? I'm sure by now you would have realized this is a very basic O-level question, right? So here, larger the resultant force, larger the resultant force. If you write F equal ma, larger the resultant force, larger the acceleration. Mass is constant, F proportional to A. Larger resultant force is seen where? Only in answer number 5. Very quickly you can do it. There. Very quickly you can do it. Okay. Larger resultant force you can see in answer number 5. Okay. Right. Next question. Next question. Two particles A and B have equal kinetic energies, but the velocity of particle B is 4 times that of A. Now they are not telling you the masses are equal. Masses are different. Okay. Masses are different. So they're asking you, velocity of particle B is 4 times the velocity of particle A. What's the ratio of the momentum here? Momentum of A divided by momentum of B. Right. Look at the board carefully. Look at the board carefully. Here you go. There is a relationship between linear momentum and kinetic energy. There is a relationship. What's the relationship? Here you go. P squared equal to me. P squared equal to me, where P is linear momentum. P is what? Linear momentum. E is going to be kinetic energy. M is going to be the mass. Now, what are they saying? Kinetic energies are equal. Kinetic energy of A is equal to kinetic energy of B. Look at the board now. Half MA VA squared, half MB VB squared. Half cancel off. MA MB we can't cancel. They are telling you velocity of B. If you want, go and check again. Velocity of B is 4 times velocity of A. Velocity of B, 4 times velocity of A. 4 times velocity of A. 4 times velocity of A whole thing squared. MA VA squared, MB 16 VA squared, VA squared cancel off. Please work with me. Work with me. That's equal to MA over MB is equal to 16. MA over MB is equal to 16. Right. How can I use this? Some of you are saying, sir, I don't know this. This is the first time I'm seeing this equation. Don't worry, I'm teaching it. Here, let's look. There is a mass m traveling with a velocity v. There is a mass m traveling with a velocity v. Momentum is equal to mass into velocity. So velocity is equal to mass divided by velocity. Velocity is momentum divided by mass. Sorry. Okay, no? Momentum divided by mass. Right. Now look. Kinetic energy is equal to half mv squared. Wherever there is velocity, let me substitute p over m whole thing squared. If you simplify this carefully, Kinetic energy is half m p squared over m squared. 1m will cancel off. Cross multiply. P squared is equal to 2me. Understood, no? So using your basic momentum equation, I have proven the relationship. Nothing difficult. Okay, right. So now they're asking the ratio of the momentum. So momentum of A squared is 2 times mass of A, same kinetic energy, divided by momentum of B squared divided by 2 times mass of B kinetic energy. Can you see? 2 cancel off, E cancel off. What is MA over MB? MA over MB is 16. That is not your answer. Be careful. They want momentum division. So PA over PB is square root 16. Square root 16 is 4. Can you see? Kinetic energies are equal. Velocity of B is 4 times the velocity of A. Simplify. From there, you can get the required relationship. Okay. From there, you can get the required relationship. Right. From there, we can easily show that. From there, we can easily show that. That's the answer. Answer is answer number. So I have shown the working earlier, so I will not use this small space. So look at this below. Here you go. Once you need it, please write it down. Right, no? Okay. Right. We'll move up. Right. The Geiger counter can be used to detect. Geiger counter. What is a Geiger counter? A Geiger counter is a device which is used to find out or study about charged particles. Okay? Charged particles. Now here, alpha particles are charged particles. Gamma rays, the gamma rays have no charge. Yeah. But gamma rays also can be detected using a Geiger counter. Yeah. So Geiger counters are used when there is high radioactive or some kind of radioactive emission. So alpha particles and gamma rays, yes. What about neutrons? Now, neutrons can be detected, any particle can be detected using a GM tube. But remember, by using a special kind of gas called boron trifluoride, we can also identify neutrons. So remember, A, B, C, all what? Correct as well. In a normal GM tube, A and B can be identified. Alpha particles and gamma rays. Alpha particles and gamma rays. Okay. So this and this both are what? Correct. Clear. That particular year, they took both of these as correct. But for now, if they ask you, Geiger counter or GM tube, short form, they call this GM tube. GM tube. GM tubes can identify all particles. Alpha, gamma, beta, beta plus, beta minus, all of that. Okay, no? Let's write. A GM tube is used to identify. GM tube looks like this. Huh? A GM tube is used to identify a GM tube is used to identify the amount of charged particles. The amount of charged particles. As the ionized particles travel through the thin mica window, as the ionized particles travel through the thin mica window, as the ionized particles travel through the thin mica window, they will ionize the gas inside the GM tube. They will ionize the gas inside the GM tube. They will ionize the gas inside the GM tube. This will cause primary and secondary and tertiary. This will cause primary, secondary, tertiary ionization. This will cause primary, secondary, tertiary ionization, which will create an electric pulse. Which will create an electric pulse. Which will create an electric pulse. And these electric pulses are taken as a count. And these electric pulses are taken as a count. These electric pulses are taken as a count. From these electric pulses, we can count the number of decay taking place. We can count the number of radioactive decay taking place. Okay, no? We can count the number of radioactive decay taking place. Right. Now, no need for you all to wait until your teacher teaches this in the last lesson. Simple thing. GM tube. Where have you seen this? Some of you all have watched so much of movies, radioactive movies. In the radioactive movies, you will see a person wearing a hazmat kit. The white color kit is called the hazmat kit. Having a small device in the hand, walking around with a beep sound. Ding, 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 ding. That beep sound indicates the GM tube. The pulses indicate what you hear. Number of disintegrations, number of decays are large means there is more radioactive decay. Understood? So this is not only radioactive decay, is disintegration. Particles emit energy and particles to come to a low energy state. So this is what you use in a GM tube. Okay, no? Right. So I'm sure that is clear. Right. Look at this now. MCQ number 7. An organ pipe closed at one end resonates with one of the strings of a guitar. Organ pipe closed at one end. Now, organ pipe is closed at one end, resonates with a guitar string. What do you mean by resonating? What do you mean by resonance? Resonance means frequency is same. Resonance means what? Frequency is same. Right. Now, here if you look, an organ pipe closed at one end resonates with one of the strings of a guitar. The length of the string is 0.8 times the length of the pipe. So length of the pipe is L. Length of the string is 0.8 L. Okay, no? 0.8 L. There you go. If both the pipe and the string vibrates with the fundamental frequency, a fundamental frequency you must draw. Fundamental frequency means string one loop. One loop. Closed tube means you can draw with the end correction, but I don't think for the MCQ we need end correction. Right? They resonate with the frequency. So this frequency here and this frequency here both are what? Same. Right. Now remember, this is speed of sound in the wire or the string. This is speed of sound in air. So I'll name this F1 and F2. F1 equals F2. Look at the board. Here F1 is the pipe. Right? F1 is the pipe. V divided by 4L. Fundamental frequency. This is velocity of sound in air. This is for the string. 1 over 2L, 0.8L. Square root T over M. Now, what is square root T over M? T over M is the velocity of the string. T over M is the velocity of the string. For the ones who can't remember, look at the board. Look at the board. Here, close pipe. Close pipe. Right. Node, antinode. Node, antinode. What can you say about the distance? Node to antinode? Lambda divided by 4. Can you see the board? Lambda divided by 4. Right. I'll use different color. Lambda divided by 4. Lambda divided by 4 is L. Lambda is equal to 4L. Lambda equals 4. Now we can say V is equal to F lambda. V is equal to fundamental frequency 4L. Fundamental frequency V divided by 4L. Now earlier I directly wrote. Here I'm showing how to get it. Once you need it, either copy it or take a photo quickly. Okay, right. Next is fundamental vibration of a string. So string is here. String is here. Fundamental vibration of a string means one loop is for. One loop is for 0.8 L. Node to node, lambda divided by 2. Lambda divided by 2 is 0.8 L. Cross multiply. Lambda is 1.6 L. V is equal to F lambda. Be careful. Velocity of the string. Transverse velocity square root T over M. 1.6 L. From this we can show F1 equal, this is for sound. What is T over M? String. String divided by, string multiplied by 1.6. String multiplied by 1.6. Right? Velocity of sound cross multiply. Oh, sorry. Here it should be 1.6. 1.6. So divided by 1.6 L. Right. These two are equal. So you can say here velocity of sound, velocity of the string. Square root T over M is going to be velocity of the string. Square root T over M is velocity of the string. If you want, write it down quickly. If you want, carefully write it down. Right now? Now let's go back. So here also, I can write directly velocity of the string. Right. What are they asking you? They are asking velocity of the string or velocity of sound. So string divided by sound. LL cancel off. 1.6 divided by 4. 1.6 divided by 4. That is equal to 0.4. That is equal to 0.4. So here your answer 0.4. Correct, no? 0.4. Right. Okay. Now interesting. O-level electronics. A-level also you learn this, but O-level. What is this gate? This is called an AND gate. AND gate with a NOT. AND gate with a NOT. AND gate with a NOT. Right. Capital La. AND gate with a NOT. So how will I draw this? AND gate, NOT gate. Like this. This is called a NAND gate. What gate? NAND gate. NAND gate. AND gate with a NOT gate is called an AND gate. Correct answer, answer number 3. Gate with a NOT gate is called an AND gate. Correct answer, answer number 3. If you have done O-level IT, guaranteed you know this. If you have done O-level science, guaranteed you know this. So no need to come up to A-levels. You all know this. Right. Look at this now. Sorry. Sit down a bit. Okay. Mass 2 kilogram moving with a velocity 1.2 meter collides with a light spring. So here there is a kinetic energy. It will collide, compress, and stop. Kept horizontally on a frictionless table, maximum compression. Look at the board. Maximum compression. What do you mean by maximum compression? Spring is here. This has compressed maximum X max and come to rest. And come to rest. So what is your equation? Very simple. Kinetic energy converts to elastic potential energy. Kinetic energy converts to elastic potential energy. Kinetic energy half mass into velocity squared. Elastic potential energy half K times X. K is 50. X maximum squared. Maximum squared. 2 and 2 cancel off. 1.2 squared is 1.44. 2 times 1, 2 times 25. Divided by 25. This is your X max squared. Right. Take the square root. X max square root you take 1.2 here. 25 square root is 5. 0.2. 0.2. 0.2. Okay, no? 0.24 meters. 0.24 meters. Do you have the answer? Yes. Answer is answer number 4. Once you need it, write it down. Right now? I'm sure all of you have got that correct. Right. What is this? Frame shows a figure made from a uniform wire. Center of gravity of the frame is most likely. Now you can imagine this. Look at this carefully. This you can take as a rod. So here the mass is at the center. 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 Right now, masses are at the center. Right? Masses are at the center. Right. Now what? Now your job is to find the center of gravity. You can apply ratio theorem. Ratio theorem. I'll do like this. If I take these two, ratio theorem means the distance here, R1, R2. This distance R1, this distance R2. R1 divided by R2 is masses will cross. M divided by M, 1:1. So here 1:1 ratio. Now the total mass here is 2m. Total mass here is 2m. Now what? Now your job is to find where this particular center of gravity of the system lies. where this particular center of gravity of the system lies. If you look at this carefully, here M and M is there. M and M is there. Here M, 3M is there. 3M is there. So all the three masses we can put together. So here the mass will be 3M. At once you can write here. I'll write in red color. All the three masses here 3M. All these three masses I have taken. Again, look carefully. I have taken two masses. I have taken two masses. These two masses are here. I have taken these three masses. All the three masses are there. So all the three masses are here. All the two masses are there. Now what is your ratio? Ratio is here masses will cross. 2:3 ratio. 3 will come down, 2 will come there. What is the most suitable location? Suitable location is D. Again, look. M, all together total mass 3M there. M here, total mass here 2M. These are taken. 3M, masses will cross. 2:3. Center of gravity is there. Okay? Center of gravity is there. Answer D. Okay? Answer D. So I will teach you all, for the ones who don't know, what is ratio theorem. That's my duty, no? Ratio theorem. Look at the board below. Ratio theorem. Right. If there are two masses, let's say M1, M2, the center of gravity will act somewhere around in between these two. At the center of gravity, total weight will act. M1 plus M2 will act. Right? So here weight you can mark M1G. Here weight you can mark M2G. At this point, total weight is M1 plus M2G. M1 plus M2G. Okay, no? This distance, if I take as R1, this distance I'll take as R2. Look at the board carefully. Remember, any mass about the center of gravity, you can balance any mass system. So about the center of gravity, clockwise moments equal anti-clockwise moments. Clockwise moments here, M2G R2, anti-clockwise moments M1G R1. GG cancel off. M2 R2 equals M1 R1. So how do you get the distances? R1 divided by R2, R1 divided by R2 is M2 divided by M1. There you go. That means R1 divided by R2 means, I'll show you clearly here. M2 comes here, M1 goes there. R1 over R2 is M2 divided by M1. There you go. So, right now, so this is your ratio theorem. Ratio theorem. From the ratio theorem only we solve the earlier problem. So when you get a system of masses, don't panic, please. Very simply, apply ratio theorem taking two masses. When you get experience, you can take what? 3 masses. Okay, no? So here, if I look at it, look at the board. You might say, sir, you are taken 3 masses here. Yes. Yeah, experience on level MCQ. M altogether becomes 3M then. M and M here becomes 2M then. Now 3M, 2M, all the other masses are taken. 2:3 means answer is answer D. Okay, no? Answer is answer D. Right. Okay. Now, good question. Here, infinitely long, thick conducting sheet. Under Gauss theorem, you will learn this. Is a standard application. Remember, thick means I will make this a bit simpler for you. I'll make this a bit simpler for you. I'll draw it here. Infinitely long. There you go. Infinitely long means this is actually infinitely bigger. This is actually infinitely bigger. Okay, no? Here on the surface, there is a surface charge density. All the positive charges are there. Since all the positive charges are there, surface charge density, I will take it as, I'll put a different color there, plus sigma. Now remember on the behind side also, we have the same thing. Okay, behind side also, we have the same thing. Right. Now, if you apply Gauss theorem, I will take you back. I'll take you back to theory. By now, you all should have done this. You should have done this in your classes. Anyways, let's say here you have a infinitely long conducting plate. Infinitely long conducting plate. Here, positive charges are there. Positive charges are there. Right. Right. So from a positive charge, electric field lines will go out. I'm sure whatever class you learn, I'm sure they would have taught you that electric field lines go out. Electric field lines go out. Right. Now, when electric field lines go out, we have to find the electric field strength. For that, we must take a Gaussian surface. So I will take a cylindrical Gaussian surface where the area here is A1. And here the surface charge density is sigma. Now, what is sigma? Charge divided by area. Area means infinite plate. So I'm taking this small area. What is the small area? This area A means here projected area. Projected area here is also what? A. No? Inside the cylinder, if I touch, the area I'm touching is A. A1. Sorry. Now, sigma equals charge there is Q1 divided by A1 cross multiply. Q1 is sigma O A1. Sigma O A1. Now, what is Gauss theorem application? Gauss theorem is E times A, sum of charges inside the Gaussian surface divided by epsilon naught. Now, what is your Gaussian surface area where the electric field lines are coming out? Electric field lines are coming out from the surface area A1. Field lines are coming out means flux is positive. E times A1. What is the charge inside? Charge inside I have found. Sigma A1 divided by epsilon naught. A1 cancel off. From this you can say E is equal to sigma divided by epsilon naught. So for a uniformly charged infinite long conducting plate, electric field strength is sigma divided by epsilon naught, independent of the distance. Does not depend on the distance. Right now? Okay. Once you need this, quickly take a photograph or something. This is your cylindrical Gaussian surface. Cylindrical, we learned this in theory, Gaussian surface. Cylindrical Gaussian surface. Right. Now, Right now. Okay. Now we have learned this. Let's switch here. Right. I'll fold it. Now look at this. From here, electric field lines are going out. From here, electric field lines are going back. Electric field lines are going forward. Electric field lines are going backwards. What do you have in the middle? Middle is metal. I will color it here. Here, this one. This one only is there. Inside the metal, there is no charge. Charges are there in a conductor on the outer surface. If I draw variation, electric field strength distance, look at the board. Towards the right, positive means here positive sigma O epsilon naught. Towards the left, it will be negative. Why? Direction is opposite. So vector no. Minus sigma epsilon naught. Okay. So what can you say here? I'll keep the gap pause. Easier. No? I'll keep the gap pause. I'll keep the gap here also. It's important. Right. Here, gap is also here. Gap is also here. Right. Okay. Gap is also kept. Right. Inside, there is no electric field. Inside the metal, no electric field. Outside, you have here positive. Here it will be negative. Negative sigma O epsilon naught. So negative sigma O epsilon naught, they have not given you direction. Sigma O epsilon naught, 0, sigma O epsilon naught. Correct answer is answer number 2. If they ask you to draw a graph, here you go. Towards the right, positive means towards the left, negative. Here positive, sorry. Here positive. Here negative. From here negative. The value is minus sigma epsilon naught. Okay, no? So your correct answer is answer number 2. Correct answer is answer number 2. Right. Once you need it, if you want, draw the graph. Once you need it, draw the graph. Right. Now a magnetic field problem. Mag field problem. A long straight wire carrying a current is placed in a uniform magnetic field at right angles to its direction in a plane perpendicular to the current. A long straight wire carrying a current. Long straight wire carrying a current is placed in a uniform magnetic field at right angles. That means perpendicular to the direction of the field. Yeah, direction of the field. So let's say there is a uniform magnetic field like this. Uniform magnetic field like this. Second shy students and all should know this. Familiarly, I think the first shy ones are maybe doing this now. Okay? Maybe doing this or going to start this. So good opportunity. Magnetic field lines are going. They are telling you perpendicular to this current is coming out. A long straight wire carrying a current is placed uniform to a magnetic field at right angles to the direction of the field. So right angle means into the board. So I am keeping a wire going into the board. This dot indicates current is coming out. Current is coming out. Right. Now they are asking you number of points having zero resultant magnetic flux. In other words, they are asking which point has a zero magnetic field strength. Already there's a uniform magnetic field. All of you all know Maxwell's corkscrew. Current is coming out means you have magnetic field lines going in circles, concentric circles. So here like this. You can see the magnetic field lines here are opposite, so they will cancel off. Magnetic fields at the bottom are in the same direction, they will add. Magnetic fields here are perpendicular, they are perpendicular, so there's a resultant magnetic field. Magnetic field here also there's a resultant. So there will be a single place, one place, where the direction of the magnetic field, I'll show you here, direction of the magnetic field is equal and opposite, to the magnetic field produced by the wire. Equal opposite means they cancel off. Cancel off means we'll have one magnetic location. Now you might say, sir, here also have. Here also might have. As you go far away, magnetic field strength will reduce. Yes, they are in opposite directions, but they will not cancel each other off. The blue color one will be bigger than the red color one. Further you go, just like gravitational fields, further you field reduces. So further you go, the magnetic field here will reduce. So even though they are opposite, they can't cancel. Closer ones only can cancel. Okay. There is only one location. Okay, no? Right there. As shown in the figure, the closer the magnetic field is to the current carrying wire, the closer the magnetic field is to the current carrying wire, the greater the magnetic field strength. The greater the magnetic field strength. The greater the magnetic field strength. Therefore, there is a high chance that the field lines will cancel off. There is a high chance that the fields will cancel off. There is a high chance that the fields will cancel off. The further we go away from the current carrying conductor, the further we move away from a current carrying conductor, smaller the magnetic field strength. Smaller the magnetic field strength. Smaller the magnetic field strength. So they cannot cancel each other off. So they cannot cancel each other off. Okay. Right. Look at the next one. One end of a stretch string is attached to a wall. When the other end of the string vibrates with a frequency F1, a standing wave is set up along the string. The tension in the string is now triple while maintaining the same number of loops in the string. So remember, F is equal to N over 2L square root T over M. Maintaining same number of loops means N is same. N is same. Length of the string is also same. Material made by the string is also what? Same. So all these are same. What is your variable? F is proportional to square root of tension. Now F1 proportional to square root T1. F2 is proportional to 3 times, no, triple, 3 times T1 square. What are they asking you? F2 divided by F1. Equation 1 here, equation 2 there. 2 divided by 1 you have. F2 divided by F1 is square root 3. Square root 3 means answer number 3. Square root 3 means answer number 3. Okay, no? Square root 3 means answer number 3. So you can see now these are not difficult. Now go and look at your theory notebooks. I'm sure your teachers have taught this. Go back, have a look. If you have gone wrong, look at the theory, correct your theory, then what? Try this question again. Then you'll be okay. Okay, now? Right. Okay. Power of a lens combination is 44 diopters. And the power of one lens is 40. Combination means together. Magnitude of the focal length of the other lens. So equivalent power is power of one lens plus power of the other lens. Lens combination 44. Power of one lens is 40 diopters. Power is equal to 4 diopters. Focal length, how do you find? Power is equal to, you put the minus and do, because the sign convention. 4 diopter means 1 over f. F is equal to minus 0.25 meter minus 25 centimeter. Minus 25 centimeter means what kind of lens? Convex lens. So here no minus sign, just 25 centimeters. Correct answer 14th one. Answer number 25. Correct answer number 4. Right. Okay. Right. Look at this question. Consider the following statements regarding Hall effect. You will learn this under Biot-Savart theorem. Yeah. Or forces acting on moving charges. Either way. Guaranteed forces acting on moving charges, you will learn this. Right. Consider the following statements regarding Hall effect. Right. Now, Hall effect means I will do it on the board. That's better. So whatever I'm doing here, make sure you make a small note. Right. Now, let's say there is a conductor. In a conductor, there is a uniform magnetic field, let's say, into the board. Remember, Hall effect can be applied only for rectangular conductors. Hall effect can be applied only for rectangular conductors. Okay, no? Rectangular conductor. Now, current is traveling in that direction. Tell me now, in a conductor, what is your majority charge carrier? Carriers are what? Electrons. Conductors means electrons. Right. So now electrons will travel in the opposite direction like this. I'll draw a few. I'll draw a few. Right. Now, that is a moving charge in a magnetic field. Fleming's left-hand rule. If you take the left-hand rule, thumb, first finger, second finger, thumb gives you force. Thumb gives you force. First finger gives you field. What? First finger gives you field. Second finger gives you current. Second finger gives you current. Second finger gives you current. Right. Now carefully apply. Field, current is going this way. Electrons are going this way, but current is going that way. Field, current, force. There will be a force on the electrons upwards. That means the electrons will move upwards. If the electrons move upwards, top will be having more electrons, so negatively charged. Bottom has less number of electrons, so you'll have what? Positively charged. Okay, no? Right. Remember, Hall voltage is the potential difference between the top and the bottom. This is called Hall voltage. Right. Now look at the board. Our main idea is not that. Let's say there is no electrons. There is no electrons. Positive charges are the charge carriers. Positive charges are the charge carriers. So current is going this way. Positive charges also going the same way. Now there is a magnetic field inside. We can apply the left hand rule. Field, positive charges going current, force. That's also upwards. Force will act on the positive charges upwards. Positive charges will go upwards. When positive charges go upwards, top will be positively charged. Bottom will be what? Negatively charged. Can you see, depending on the negative charge or the positive charge, the top and bottom charges or the signs will change. Understood? So depending on the charge carriers, the top or bottom is bottom, positive will change. Current is going in the same direction. You can see. Same direction current is. Right. Now look. Now look. The sign positive or negative is independent of the sign positive or negative of the current carriers inside the metal. True or false? True or false? Now you know. Now you know. Charge carriers are negative means top is negative, but bottom is positive. Charge carriers are positive means top is positive, bottom is negative. Polarity will what? Change. So is it independent or dependent? Is it independent or dependent? The word independent here indicates it's wrong. It's going to be dependent. Understood? Okay, no? Right. Hall voltage is not generated when the direction of the magnetic field is parallel to the direction of the current. Right? No? Left hand rule. Current and field are perpendicular. If they are parallel, do you have a rule? No rule. There is no rule like this. No rule. So this is also correct. Because you are applying Fleming's left hand rule. Hall effect is a consequence of force acting on moving charges in a magnetic field. True. B and C correct. Answer number 3. So simple question they have asked you. Simple question they have asked you, which the answer I have put on the board. Negative charges going, polarity will be different. Positive charges going, polarity will be different. Why? Because forces are acting on moving charges. Force acting on moving charge. Force acting on moving charge. Fleming's left hand rule. Fleming's left hand rule. Okay, no? So Fleming's left hand rule. Take the thumb, first finger, second finger perpendicular to each other. Fleming's left hand rule. Fleming's left hand rule. Okay, no? Right. Okay. I'll move on. A uniform wire L is fixed attains proportionality limit. Now, Hooke's law. When a mass M is hung from the other end. If a length L over 2 of the same wire is used, the proportionality limit will attain when what mass is hung? Common sense. I take a long copper wire and hang a mass, proportional limit is reached. I take a short copper wire. Proportionality is reached at different masses or same mass. Remember, proportionality limit is a property of the material. Whether it is long or short does not depend on the effect. Whether it's long or short, proportionality limit is going to be what? Same. What do you mean by proportional limit? Proportional limit is the limit which it will obey Hooke's law. Okay. So here, if you take the force extension graph or stress strain curve, after this, yes, it might change a bit, but up to this, the load is always what? Same. Won't change. Okay. So here, up to the proportional limit, the mass will be, of course, the same. So 16th one, correct answer is answer number 3. Because proportionality limit is not depending on the length, depends on the material, right there. Proportionality limit does not depend on the length of the wire. Does not depend on the length of the wire. Only depends on the type of material. Only depends on the type of material. Okay. Right. A uniform wire is cut into 3 equal pieces. When they say 3 equal pieces, remember O level, R rho L over A for resistance. Same material means same row, same area, length is same means resistance is same. R. Resistance is same. Right. Ammeter A2 reads, this ammeter is 1.2. Then the reading in ammeter A1 is, right. Some O-level work, but there is no problem. All these 3 resistors are parallel to each other. These 2 resistors are parallel, so I can write like this. Equivalent resistance R divided by 2. Here there is another R going. This is for C. This is for A and B together. A and B together. Right. Here current is 1.2 amperes. Here current is 1.2 amperes. They want the current that is going to go through here and divide. So total current here across A and B. They want this current here. Now remember, you will learn something called current divider in elements. Current divider means directly you can find this current. How? Don't take that resistance. Opposite one. R times total current 1.2 divided by the addition. R plus R over 2. Remember this, huh? So here, how do you find the current here? Resistance times total current divided by the addition. Simplify this. I1 1.2 R divided by 1.5 R, 1.5 R. That's going to be 405, 0.8 amperes. 0.8 amperes. There you go. So how do you find the current here? Don't take that resistance. Opposite into total divided by the addition. Opposite into total divided by the addition. So these are small tricks which you will learn in electricity. Okay. Which you will learn in electricity. Right. Consider the following statements made about a PN junction. You learn this in O levels also. In a PN junction, the IV characteristic is linear, it's true or false? PN junctions are non-linear, does not obey Ohm's law. First one is wrong. There is a built-in electric field across the junction directed from the N region to the P region. Right. Look at this. What do you mean by PN junction? Here, let's say PN junction. This side becomes negatively charged. This side becomes positively charged. When a P-type and an N-type semiconductor are brought to each other because the electrons rush. When the electrons rush, now you can see there is an electric field created here from the positive to the negative, N-type to P-type. So N to P region, B is correct. Currents carried by holes and electrons are in opposite direction. Wrong. Current is same. Now here, what happens is electrons rush inside if you forward bias this. Positive, negative. Huh? Here there is excess electrons. These excess electrons will go towards the positive terminal. Here there is less number of electrons. Negative terminal will supply the electrons. Negative terminal will supply the electrons such that electrical neutrality is maintained at the junction. Now you can see electrons are going in that direction. Current will go in the opposite direction. What about the holes? Holes are going from plus to minus. Plus to minus means current is going in the same direction. So you can't be opposite directions. C is wrong. Only correct statement is B. Only correct statement is B. Right there. Right there. The PN junction has an electric field directed from the N type to the P type. Has an electric field directed from the N type to the P type. N type to P type. When we forward bias it, excess electrons in the P type will go to the positive terminal. Excess electrons in the P type will go to the positive terminal. And there is less number of electrons in the N type. And there is less number of electrons in the N type. Less number of electrons in the N type. The negative terminal will supply. The negative terminal will supply. There is only one current carrying direction. There is only one current carrying direction. Okay. Right. Okay, no, these are your O-level knowledge actually, not A-level even, but you would have forgotten. So you can draw this roughly. Some of you are asking, what's the IV curve like? So IV curve is actually like this, no? And go down. Wait, there is no space there. I'll erase this and draw. Right. IV curve. Here, if you draw it, after here it will drop. We call that breakdown voltage or Zener voltage. This is your, if this is silicon, this is 0.7 volt. If it's germanium, 0.3. Okay, no? So this is not a straight line, this is going to be a curve. Huh? Right. Okay. Right. Look at the board now. They are telling you here something pretty interesting. Right. Two monochromatic lights, A and B, after passing through the optical element P, emerge as shown in the figure. Top ray is coming from the bottom, bottom ray is going from the top. Right. How can this take place? Actually, only a prism can do this. Look at the board carefully. Right angle. One ray comes very close. One ray comes from far. Ray coming from top. Bottom ray goes to the top. Top ray comes to the bottom. Prism. Right angled isosceles prism will do the trick. Okay. Right angled isosceles will do the trick. Right. Aluminium Young's modulus is given. If you have done thermal physics, I'm sure you have done this. When it warms to 34, the force exerted, thermal stress, A Young's modulus alpha delta theta. Area here 20 centimeters squared, convert to meter squared. Young's modulus 7 10 to the power 10. Alpha 2.5 10 to the power minus 5. Change in temperature, be careful. 30 to 40, that's 4 degrees Celsius. Simplify this. 25 times 50. 350 times 4. 50 times 7, 350. 350 times 4. Powers 10. 0, 0, 14, 0. How much? 1.4, 10 to the power 4 newtons. There you go. 1.4, 10 to the power 4 newtons. Right. So these are thermal stress questions. Thermal stress question. You can check your theory notes. Thermal stress. Right. Then I gave a structured essay. So all I have done these now. Huh? So what is the structured essay telling you? A man X pulls a wooden block B along a rough horizontal surface with a horizontal rope R. A Roman 1 indicates on the diagrams given the next page the horizontal forces acting on box B and R. Use the following notations to label each force. Okay, let's label it. FRX, force exerted by the man on the rope. You should be on na. FRX. Force exerted by the box on the rope. By the box on the rope. Force exerted by the rope on the box. Same line of action. Don't forget. Same line of action. FBR. Friction here. There you go. I'm sure you have marked this correctly. I'm sure you have marked this correctly. Okay. Right. Which of the following forces can be considered action-reaction pairs? What do you mean by action-reaction? Every action has an equal and opposite reaction. Action-reaction will act on two separate objects. So FRB, FBR. Rope is pulling the box, box is pulling the rope. FBR, FRB. FBR and FRB. FRB. Right. When the man pulls the rope with a force 100 Newton, the box still continues to remain stationary. What is the frictional force acting on the box? Keywords I have underlined. Now I'm applying a 100 Newton force. Look at the picture. 100 Newton force. 100 Newton here. Box is at rest means rope is also at rest. That means resultant force is 0. So on the rope also this is 100 Newton. Equal opposite, that is 100 Newton. How can this be at rest? Friction force is also how much? 100 Newton. So friction force will be 100 Newton. Friction force will be 100 Newton. Here you go, 100 Newton. 100 Newton. Easy, no? Right. When the man pulls it 150, the box is on the verge of moving. What do you mean by the verge? What do you mean by the verge? Just about to move. Is it moving? No. It's at rest. So verge of moving means just about to move, but still not moving. Right. Now what? Now what? Look at this carefully. Yeah. Here 150 Newton. On the verge of moving, rest. Here also 150 Newton. Sorry. Here was 150 Newton. Here was 150 Newton. On the verge of moving. On the verge of moving means still rest. Don't forget. So friction force is 150 Newton. Friction force is 150 Newton. Write there a small sentence. When the object is on the verge of moving, when the object is on the verge of moving, still the object remains at rest. Still the object remains at rest. There will be maximum static friction acting on the object. Maximum static friction acting on the object. There will be maximum static friction acting on the object. Right. Okay, moving on. If the mass is 50, calculate coefficient of static friction. You can write now. Limiting friction Fs max. That is mu s into normal reaction. Limiting friction is 150. Mu s we don't know. Look at the board. Look at the board. Look at the board. There you go. Normal reaction 50 kilogram 500 Newton. So normal reaction is 500 Newton. Normal reaction is 500 Newton means you can substitute here. Mu s is 150 divided by 500. 0.3. 0.3. Okay. 0.3. Right. When the force exerted is increased to 200, box will start to accelerate. Now I'll draw the rope here. I'm increasing the force to 200. Force acting on the rope by the box, FRB. Mass of this is 1 kilogram. Apply F equal ma forward on the rope. Simple work. 200 minus FRB, mass into acceleration 2. FRB is equal to 198 Newton. Now you can apply on the box. FRB means FBR here. Force on the box by the rope. Friction force is here. 500 Newtons there. Normal reaction here. What are they asking? Calculate the force exerted on the box by the rope. Done. Calculate the friction force acting. Apply F equal ma on the box. Apply F equal ma on the box. Look at the board. Applied force FBR, FRB 198 minus friction, mass into acceleration 2. 198 minus 100, F is equal to how much? 98 Newton. 98 Newton. Then what? Determine the coefficient of kinetic friction. Coefficient of kinetic friction, Fk is equal to mu k into R. Fk is equal to 98. Mu k we don't know. Normal reaction 500. Mu k equals 0.981. 480 we don't have. 4,800 you have 9. 4,500. 300 you don't have. 3,000 you have what? 6.196. Right? No. Coefficient of kinetic friction is smaller than static friction. Okay, no? Right. This is the essay question. Okay. This is the essay question. Right. Wind blows along a horizontal direction on an open space at constant speed v. Write an expression for the kinetic energy per unit volume. Kinetic energy is half mv squared. I want kinetic energy per unit volume. I divide both sides by volume. Okay. Right. Now look at this carefully. What is mass over volume? Mass over volume is density. Half rho v squared. Half rho v squared. So there you go, your answer. Half rho v squared. Kinetic energy per unit volume. Kinetic energy per unit volume. Very simple. Divide both sides by volume. I get the answer. Okay. Right. Kinetic energy carried out by the blades of the windmill and is subsequently converted into useful energy. What's happening? The kinetic energy of the wind rotating blades is converted to useful energy like electricity, rotating a turbine. Consider the situation where the wind is blowing normal to the plane of a rotating blades. Area swept by the blades, remember these cubes. Assuming that all the kinetic energy of the wind through the cross-section area A is extracted by the blades, show that the rate at which wind energy is transferred to the windmills is given by half rho A V cube. The cube is not printed. Half A rho V cube. Right. What is happening? Blades are there. This is your effective area. This is your effective area, capital A. What is happening? Wind is blowing through. Air is traveling through. What are they asking you to find? Kinetic energy through the blades. Rate at which kinetic energy is transferred. So what is kinetic energy? Half mass into velocity square. Rate of kinetic energy means kinetic energy over time. So half mass over time into v square. What is mass over time? Newton's law. Mass flow rate. In Newton's law, you learn this. M over T is mass flow rate. Mass flow rate means area, velocity into density. Look at the units. Meter squared, meter per second, kilogram per meter cube. Meter squared, meter cube, per meter cube cancel off. Kilogram per second. AV rho. Substitute here. Half AV rho times V squared. From this we can say, but rate in which kinetic energy is transferred. That means power. Kinetic energy over time is power. Half A rho V cube. Half A rho V cube. There you go. Half A rho V cube. Okay, now? Right. So don't forget, sometimes you all might have forgotten this mass flow rate. They're asking the rate in which kinetic energy flows. So rate means kinetic energy divided by, mass, kinetic energy divided by time. That means mass over time will come. Mass over time means mass flow rate AV rho. Right now? Okay. When a certain windmill, the blades are found to be rotating at a constant angular speed 30 revolutions per minute. When the speed suddenly stops, the blade come to rest in 2 minutes due to frictional forces. If the moment of inertia of the system of the rotating blades is 10,000 kilogram meter squared. Oh, now they are connecting this to a rotational motion problem. Certain windmill is free running. Free running means no forces, no torques. Blades are found to be rotating at 30 revolutions per minute, RPM. 30 RPM. Remember, find omega. 2 pi 30 over 60. That is going to be pi radians per second, right? The wind suddenly stops the blades, comes to rest in 2 minutes, 120 seconds. Final angular velocity is going to be 0 radians per second. Initial pi, final 0, 120 seconds. Calculate the average frictional torque. Calculate the average frictional torque. So there is frictional torque. We can apply work energy principle. Work done by, right blue color, work done by external torque. Now, if there is an external torque, it will speed up. It won't slow down. Increase in rotational kinetic energy. Increase in rotational kinetic energy. Plus work done by resistive torques. If you have done work energy power in any class, I'm sure you have done this. Work done by external torque equals increase in kinetic energy plus work done by resistive torque. Work energy principle. Is there an external torque acting here? No. If there was an external torque, this is speed up. Now it's slowing down. No external torque. Increase in kinetic energy. Final kinetic energy is 0. Initial half I omega naught squared plus work done by resistive torque. What are they asking? Average frictional torque. Average frictional torque on the system. So work done by frictional torque into theta. This is your frictional torque, resistive torque. Take this to the other side. Half I omega naught squared resistive torque into theta. Now be careful. How much angle has it rotated? You can find it here. You can find it. You must actually find it. I'll find it here. Will right here. theta equals omega plus omega naught divided by 2 into t. Omega is pi, omega is 0, omega naught is pi divided by 2 multiplied by 120. Theta is equal to 60 pi. Okay, substitute now. Substitute. Right. Half I 10,000. What is omega naught? Omega naught is pi. Omega naught is pi. Pi squared. Frictional torque 60 pi. Now you can simplify this. Pi, 1 pi cancel off. 2 times 1, 2 times 5,000. 2 times 5,000. Here 0, 0. Now, if they have not given to take pi as 3, 500 pi divided by 6. That is your resistive torque. 500 pi divided by 6. Let's say it's 3. 3 over 2. So 250 value will come. But here 10,000. 10,000 becomes 5,000. Rotating angle is 60 pi. 10 goes off. 5 pi cancel off. 500 pi divided by 6. 500 pi divided by 6. So 500 pi divided by 6 means approximately, okay? Approximately. If I take pi as 3, 3 times 2, approximately somewhere 250 Newton meter. But remember, if they have not given, I can't take pi as 3. In that situation, don't take pi as 3. In that situation, don't take pi as 3. Then frictional torque 500 multiplied by 3.14 divided by 6. So here, if you multiply it, 500 multiplied by, I'll quickly multiply it here because I'm also working with you all. So here, 500 multiplied by 3.14 divided by 6. 261.66 or 67 Newton meter. Or you can say 261.7 Newton meter. Or approximately 262 Newton meter. Either way, it's correct. Either way, it's correct. So this is work energy principle for rotating motion. You can see nicely the answers will come. Nicely the answers will come. Right. Okay, no? Quickly we'll finish it. 2 more. Hence, calculate the rate at which wind wheel is extracted. Rate of energy means power. Power means everything is extracted. No? Loss in kinetic energy divided by time. Loss in rotational kinetic energy divided by time. If you write it, half I omega square divided by time. Time means how many seconds? 120 seconds, 2 minutes. From this, you can find the power. From this, you can find the power. Power will be how much? 500 multiplied by 3.14, let's say, divided by 120. Divided by 120. So 5,000, 3.14 multiplied by 3.14 divided by 120. Here you go. How long does it take? Let me look at the time. Time is 120 seconds. Time is 120 seconds. 120 seconds means loss in kinetic energy. Loss in kinetic energy, half I omega squared. Please remember your omega. I think we have to substitute the correct one. I have substituted lesser. No? So omega is correct, pi. Omega is correct, pi. Right. Sorry. If I go up, okay. From here, we can get the answer around 410.8 watt. Approximately 411 watt. Approximately 411 watt. Okay. Approximately 411 watt. Right. So loss in kinetic energy. Power is loss in kinetic energy. Useful work. Torque into theta divided by t. Torque into omega also you can take. Here loss in kinetic energy divided by time. Roman 5. Roman 5. If the velocity of the wind is 10 meters per second, area swept by the blade is 30. Density of air is so much. Find the efficiency of the windmill when it is in free running state. Energy input. Energy input. Energy input half mass into velocity squared. Here divided by time. Here divided by time. Mass flow rate. Half mass flow rate AV rho times V squared. Half A rho V cube. Half A rho V cube. Right. Half A rho V cube. Simplify this. Multiply it. You will get 1000 multiplied by 1.3 multiplied by 50. 19,500 watt. Energy input. They are asking the efficiency. So what is the useful work taken out? 411. 411. So efficiency is energy output per time over energy input per time multiplied by how much? 100. Simplify this. You can do the substitution. Energy output, earlier we have found. Energy output, how much? 411, let's say we do. 411. Energy input, 19,500 multiplied by 100. Simplify this, you can get the efficiency. Efficiency is anyway output to input. Here you will get 2.1%. 2.1%. Efficiency is 0.1%. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. Okay, no? Right? Done. Again, look at that question quickly. So there's a windmill blowing. Kinetic energy per volume is half rho v squared. Kinetic energy divided by volume. Mass of volume is density. Now, they're asking the rate in which kinetic energy flows. Rate means power, no? M over T mass flow rate, AV rho. So this answer will come. Then they are telling it's free revolutions, 30 revolutions per minute. So 30 RPM over 60, 5 radians. 2 minutes later, it comes to rest. The final omega 0. Simplify this. 120 over 2, 60, 65. Theta is 65. Work done by external torque is not there. Increase in kinetic energy is actually a loss. Final minus initial. Work done by resistive torque is frictional torque into theta. Take this to the other side. Substitute now. Simplify it. Check whether the calculation is correct. I also did with you all. 262 Newton meter. Hence, calculate the rate in which wind power is extracted. So, loss in kinetic energy over time. Loss in kinetic energy is half I omega squared, 411 watt rate of the energy extracted. Output. Wind is coming in, input can be found 19,500. Output is 411. From there, you can find the efficiency. Okay, no? From there, you can find the efficiency. Right. Okay. Right. So that concludes day number 1. I hope it was productive. Please keep working. 20 MCQs done, 1 structured, 1 essay. If you have the time, finish the work today, but at least before you go to sleep, quickly look through the work that you have done. Okay, no? Okay, then. As always, make sure that you keep working. Don't give up. Always keep moving forward. Your mindset is exactly what will determine where you end up. Okay. I'll catch you tomorrow again. Tomorrow, day number 2. The ones who have not done it, do it. Get ready. In Sinhala, I'll also tell because some of you all might be Sinhala medium also joining. වැඩේට දැන් සෙට් වෙන්න. අනිවාර්යෙන් වැඩේට සෙට් වෙන්න. දැන් සෙට් වුණොත් තව සති 24කින් හොඳ ගේමක් ගහගන්න පුළුවන්. මේ කරන්නේ හොඳ ගේමක් ගහගන්න පුළුවන් වෙන වින්දා. හරිනේ? එහෙනම් අනිවාර්යෙන් වැඩේට සෙට් වෙන්න. සෙට් වුණොත් නියම රිසල්ට් එකක් ගන්න පුළුවන්. ඒ ගේම තමන්ම කරන්න ඕනේ. මේ වැඩේ තමන්ම කරන්න ඕනේ. මේ ගේමට බහැලා බොක්කෙම්ම බහැලා කළොත් අනිවාර්යෙන්ම මොකද්ද රිසල්ට් එක එනවා. So remember, put your heart, soul, mind into it. Guaranteed what? You will get the result. Okay then. Stay home safe. Good night. I will catch you all tomorrow.